Electric components. In earlier classes, you might have learned about electric circuits. Let us revise our understanding of electric circuits by making an electric circuit. Can you recall some of the electric components that you read last year? Collect a bulb, electric wires, electric cells, iron nails, and a metal clip. Now draw a rough diagram of the circuit you want to make using the components that you have collected. We can make a switch using iron nails and metal clip as shown on the screen. Connect all the wires as depicted in the circuit diagram. Now switch on by clipping. Glowing bulb shows that your circuit diagram is working. If you are asked to draw the same circuit on a paper, you might find it difficult to draw most of the components. Until and unless you are a good artist. Don't you think there should be an easy way of representing each electric component so that it can be easily drawn on paper? Heating effect of electric current. Have you ever thought, how does the television heat up if it is switched on for more than 2 to 3 hours, or the mixer grinder becomes hot while using? What does make an electric device heated? Let us do an experiment to understand the heating effect of electric current. Take a beaker and fill it with water. Now take a nichrome coil. It is the glowing coil in a heater. Immerse the nichrome coil in water and connect it with an electric circuit as shown. Remember that a battery of at least 4 cells should be used. Now put the thermometer into water. Note down the reading of thermometer. Now switch on the key and wait for 5 minutes. Now switch off the key and again take the reading of thermometer. What do you observe? The temperature of the thermometer has increased. What did increase the temperature of water? As current was flowing through the nichrome wire for a time period, it heats up the wire. Water in which nichrome was immersed absorbs the heat of nichrome and hence its temperature gets increased. So we have seen that when an electric current flows through a circuit for a long time, a heat is produced in the circuit. This is termed as the heating effect of electric current. Many electrical devices work on the phenomena of heating effect of electric current. Let us study about them. Electric bulb. The filament of the bulb is heated up on flowing current through it and hence produces light. Electric heater. The nichrome coil of the heater is heated up rapidly as current flows through the heater, and this heat is radiated to the surroundings to keep the room warm. Electric iron. The electric iron consists of thin metal plates which get heated on passing current through the iron. Thus it can be used to iron clothes. Electric fuse. Electric fuse is a safety device in an electric circuit which prevents short circuits. The magnetic effect of electric current. Do you wonder why are you asked to stand behind a yellow line at the metro platform? It is because metro are run using electricity and it can pull you towards it. This is called magnetic effect of current. To understand the entire concept, let us do an activity. Make an electric circuit having a cell and a switch and keep the switch in off position. Take a magnetic compass near to the wire. Now turn on the switch and look at the needle of the compass. What do you observe? As we switch on the circuit, magnetic compass needle changes its direction. It is because when we switch on the circuit, current flows through the circuit and a magnetic field is created around the wire. This results change in the direction of the needle of magnetic compass. It means that the current carrying wire behaves as a magnet. It was first observed by the scientist Hans Christian Ørsted. He described the phenomenon of magnetic effects of current as, when an electric current is passed through a conducting wire, it behaves like a magnet. This effect is applicable in many devices like electromagnets and electric bell. Electromagnet. When an electric current is passed through a wire wound around an iron bar, the bar behaves as a magnet, and this magnet is called electromagnet. Let us make our own electromagnet. To make an electromagnet, we need some insulated copper wires, a bulb, a nail, battery, and some paper clips of iron. Remove the plastic coating from the copper wire at both the ends. Wound one copper wire on the nail in one direction. Make sure that the copper wounding does not overlap. Now connect one end of copper with the terminal of the battery, and the other end of the copper wire with the terminal of bulb. Connect other terminal of the battery to the bulb. Our electromagnet has been made. Now let's place the paper clips near the iron nail. You will find that the iron-made paper clips get clanged onto the iron nail. If we disconnect the battery, the nail does not remain as an electromagnet. This means an electromagnet is not a permanent magnet. This is the principle used in electromagnet. There are many applications of electromagnet. Very strong electromagnets are used to carry heavy loads. They are also used to collect iron from scrap. They are also used in toys.